Good afternoon to all of you. I hope all of you are doing well. So today we will start with our seventh objective, that is to move a sequence of byte from a set of specified address location to another set of specified address locations, right? So to understand the problem in hand, now let us consider a scenario. So we have 10 address locations starting from F000 to F009, right? So we have 10 address locations starting from F000 to F009, where the values are arbitrarily placed prior to the execution, right? Okay. So the task in hand is to copy the content of F000 to F009 to address locations starting from F00A to F013. So now what we need to do is we need to move a sequence of bytes from a set of specified address location to another set of specified address location. So this would be the eventual result. So F00A to F013 will now have 0A to 0T. So this is the task that we have in hand, right? So now I prepare the concept notes. The concept note goes as follows. So here, first DE pair, because we are working with address, so we need a register pair to hold the address. So DE pair is holding the starting address of the source sequence, that is F000. Likewise, BC is holding the starting address of the destination sequence, that is F00A. And H is holding 0A, that is 10, because we need to execute the process for the process for 10 number of times. So here DE is holding the starting address of the source sequence, BC is holding the starting address of the destination sequence, and H is holding the number of execution that is to be done, right? So now here just see what we have is we have asterisk DE. This represents a kind of indirection operator, like a pointer. So what I'm doing is I'm initializing A with the value stored at the address held by DE pair. Now the value stored at the address held by DE pair, so DE is holding F000 and the value stored at F000 is 0A. So now the value stored at the address held by DE pair is being moved to A. So A will now have 0A. Likewise, the content of A is being moved to the location whose being address is held by BC pair. So BC pair is holding the starting address of the destination sequence. So now the content of A will be moved to F00A. So from F000, the value is getting extracted and placed to A, and from A, the value is being placed to F00A, so the destination sequence, right? So this is the way how it actually works. So this is asterisk is basically used for representing indirection operator, because this is a kind of pointer notion, right? So now, out of 10 values, what we have done is we have copied or we have moved one value. So what I need to do is I need to increment both the source register as well as the destination register. Now DE is to be incremented to point to F001 as well as BC is to be incremented to point to F00B, right? So out of 10 times we have done it one time, so we need to do it 9 more times. So H is decremented by 1. So the process repeats for 10 number of times, right? Again, I'll repeat it. So here, the content of the address location held by DE pair is being moved to A. Then content of A is being moved to address location which is held by BC pair, right? Then once the content is transferred from the location whose address is being held by DE pair to a location whose address is being held by BC pair, then what we need to do is we need to increment, because we need to move to the next address location. So DE pair is incremented as well as BC pair is incremented, and out of 10 times we have done it one time, so I need to do it for 9 more times. So value of H is decremented to 1 and the process repeats, right? So now let us translate it into a representation using 8085 instruction set. So here the first instruction that we have is LXID. Now what it does is it loads the register, that is DE pair, with the 16-bit immediate data. Now just see what is the 16-bit immediate data that you have. That is F000. So F000 is moved to the register pair, that is DE. Likewise LXIB, it moves 16-bit immediate data to the register pair BC, right? Okay. So here in the first case, it moves or loads the register pair DE with the 16-bit immediate data. Likewise, here it loads register pair BC with the 16-bit immediate data, right? So DE and BC will now be holding the starting address of both the source sequence and the destination sequence, right? Now here H is having a value 0A because I need to execute the process for 10 number of times. So 0A in hex is 10, right? Now I need to create an iteration with a particular label. So here what I have is I have label L1. In that particular label, what I have is I have LDAEXD. So LDAEXD basically implies load the accumulator with the content of the address location L by DE pair. So again I'll repeat it. It stands for load the accumulator with the content of the address location L by DE pair. So DE is holding F000. So the content at F000 was 0A. So 0A is getting loaded to A. Likewise, store the content of the address of the accumulator to the address location which is held by BC pair. So now BC was holding F00A, if you remember. BC was holding F00A, if you remember. So at that address location, you are storing the content of the accumulator. So what is happening is that content of the source address location is getting copied into the destination address location. Again, I'll repeat it. LDAEXD basically means load the accumulator with the content of the address location held by DE pair. So DE pair is holding address location F000. So at F000 the content was 0A. Now 0A is being moved to A. Likewise, now A has 0A. So 0A is getting stored at the address location that is held by BC pair. So BC pair is holding F00A. So at F00A, 0A is getting transferred, right? So now then what I have to do is I need to increment the DC pair as well as BC pair, DE pair as well as BC pair. So now INXD. So it's a 16-bit increment of DE pair. INXB, it's a 16-bit increment of BC pair. Now DCRH, it's an 8-bit decrement of H. So now what I need to do is unless the value of H does not become 0, I need to repeat the process, right? Okay. So here just see there's a typo error that is 10. That's not actually 10. This is 0A. Okay. So whenever you translate it, please write 0A because this is 10. This is not 10. Right. So this is the way how a sequence of bytes from a set of specified address location is transferred to other set of a specified address location, right? So the opcode representation and the placement in the address location can be done by yourself. Now we'll move on to the next program, that is our next program or next objective, that is to move a sequence of bytes from a set of specified address location in reverse order to the source address location. Now just see what does it basically imply is F000 to F009 is the source address location, right? Okay, the source address is F000, right? Okay, the starting address of the source sequence is F000, right? And it has a sequence of bytes in it. So now what I want as a result is the reverse of the same the existing sequence to be stored in the source itself. So what I want is I want to reverse the entire list. Eventually at F000 what I want is I want 1D, right? F001 what I want is I want 1C, and F002 what I want is I want 1B. So what I want to do is I want to reverse the entire list. So this is the task that we have in hand. So what I need to do is I need to reverse the content of the specified address location. So here to progress on with the solution, so what I'll do is I'll copy the sequence from the source in reverse order in the specified destination, right? Okay, and then I'll copy the destination content of the destination to the source back. So this is the way how I'll execute it. So step 1 would be to copy the content of the source in reverse order to the destination address location, and then step 2 would be to copy the content of destination address location to source back. Right. So this is the way how the progression is to be done. Now I've prepared a concept note. So it's similar to that of the previous problem. So just see here Now, first DE is loaded with F triple zero. So DE pair is loaded with F triple zero because F triple zero is the starting address of the source sequence, right? Okay, and BC is loaded with F013. Now F013 is the terminating address of the destination sequence because I want to store it in reverse order, right? Okay, so F triple zero is the starting address of the source sequence, whereas F013 is the terminating address of the destination sequence, right? Because I want to store it in reverse order. So what I'll do is I'll move the content of F triple zero to F013 and then increment DE and then decrement BC. So that is the objective, right? So now here 0A. So because I need to move 10 bytes, sequence of 10 bytes. So H is initialized with 0A. Now I've created an iteration. Just see. A is equals to asterisk DE pair. So A is loaded with the content of the address held by DE pair. Once A is loaded with the content of the address location held by DE pair, then A is moved to the address location to the location whose address is being held by BC pair. So the content of F triple zero is being moved to F013. Now what I need to do is I need to increment DE pair, but I need to decrement the BC pair, right? Because DE pair has to move forward and BC pair has to move backwards, right? Again, and H minus minus. So out of 10, I've done it one time, so I need to do it 9 more times. So the process has to be repeated, right? So I've created an iteration. Now once that is done, I've reinstated the value of H20A because in the by the end of the previous operation, H has become 0. That is not what is expected. So what I need to do is I need to reinstate the value of H to 10 because I need to repeat the process again. Again, DE pair is loaded with F triple zero. Just see, DE pair is loaded with F triple zero because I need to now reinstate the reverse the reverse sequence from the destination to the source address locations, right? So DE is again reinstated to F triple zero because by the end of the previous execution, DE had incremented to address location somewhat like F013. So that is sorry, F009. So that's what we need to reinstate. So DE is now F triple zero, right? So now again what I'll do is I'll create an iteration. So the content of BC pair, right? Content of BC pair. Now BC is currently pointing to the starting address, that is F00A. So BC is pointing to F00A. So content of F00A is being moved to accumulator. Then the content of accumulator is being moved to the address location held by DE pair. So address location held by DE pair is F triple zero, right? Okay. So the content of F00A is being moved to F triple zero. So now both are to be incremented, that is DE pair as well as BC pair is to be incremented, right? Because now both moves forward, and then H is to be decremented by 1 because out of 10 times we have executed it one time and the process has to repeat for 9 more times. So again the iteration has to be created, right? So this is a very simple conceptual representation for reversing a sequence of bytes stored in a specified address location, right? So here now what we have is we have an equivalent representation using 8085 instructions. So as in the previous program, we have LXID comma F triple zero, LXIB comma F013, right? Then MVI H comma 0A because we need to execute it 10 number of times. Then LDAXD, then LDAXB, INXD, DCRB. Just see here we are decrementing B because D has to move backward in the eventual instance, right? Then DCRH, right? And JNZ L1. So again we keep creating an iteration here. So MVI H comma 0A. So I need to reinstate the value of H. I need to reinstate the value of the DC pair, right? Again, DC pair. Again, then what I need to do is I need to move DC both forward, DC, D as well as BC forward, right? Again, meanwhile, what I need to do is I need to continuously store the values in the source address location, right? Okay, so this is the way how it actually works, right? So this is a very simple program that is capable of storing the reverse of the original sequence in the source destination source address locations itself, right? Okay, so this is the eighth objective that we had. Now Let us move on to the next objective, and it's very interesting objective, that is finding factorial of a number, right? Okay, you must have all found factorial of a number. So here, let us considering we are finding factorial of a number 5, factorial of number 5. So here, let us consider d is keeping track of that particular number. So d is initialized with the number that we want to find factorial of. So now what we are doing, what we are supposed to do in the initial instance is that whenever we are finding factorial, we need to perform successive addition. Now successive addition has to be performed over several iterations. So that is the important thing that you need to remember. In case of factorial of a number, successive addition is to be performed over sequence of iterations, right? Again, so now initially value of d is 5, so we're finding factorial of d, that is factorial of 5. Now 5, I'm retaining it at c, right? So 5 is getting retained at c because I need to start addition from 5, right? So now d is getting decremented to 4. Now why d is getting decremented to 4 is because I need to know how many times addition has to be performed, right? So that means in the initial case, 5 is to be added 4 number of times. Okay, 5 is to be added 4 number of times, so to get 20. Likewise, 20 is to be added 3 number of times to get 60. 60 is to be added 2 number of times to get 120. And 120 is to be added 1 number of times to get 120 further. So that's factorial of 5. So that is the way how the progression is done. So here initial value of d is 5. 5 is being retained. 5 is being retained in C, and then d is decremented to 4. Right. So now here, so now further, the value of d is getting is retained. D is getting retained at e because in each iteration of factorial, right, it may so happen that the count of addition needs to be decremented, right? Okay, so count of addition needs to be decremented. So in order to remember the number of addition to be performed in successive iteration, so what we have done is we have retained the value of d to e, right? Okay, so here initially d is 5, so d is getting retained to c, right? Okay, now after that d is getting decremented by 1, and then the value of d is getting retained to e, right? So that what we can do is we can perform successive addition as well as we can perform iteration successfully, right? Now to see, the initial value of a is 0 because any operation that needs to be performed has to be done using the accumulator. So accumulator is 0 here, right? Accumulator is 0 here. So now let us start with the addition. So in the initial iteration of the factorial, I need to add 5 4 number of times. Okay, right? I need to add 5 4 number of times. So 0 plus 5 is 5. So we have added 1 time. So we need to add 3 more number of times. So 5 plus 5 is 10, right? Okay, so we need to add 2 more number of times. So 10 plus 5 is 15. 1 more number of time. So 10 plus 15 plus 5 is 20. So 1 4 is a representation of 20 in hexadecimal. So 1 4 is a representation of 20 in hexadecimal. So now e has become 0. So now what I need to do is I need to start the next iteration. I need to start the next iteration with the last value of a as the input value, right? So this is not 1 0, this is a typo error, this is 1 4, sorry. Okay, this is 1 4. So in the next iteration what I need to do is I need to perform addition 1 less than that of the previous iteration. So what I'll do is I'll decrement d by 1, so d becomes 3, and that value is getting copied to e, so it's getting retained to e. So e also becomes 3. So now again value of a starts from 0. So 0 plus 20 is 20, right? Value of e becomes 2. 20 plus 20 is 40. 20 plus 20 is 40. So value of e becomes 1, right? 40 plus 20 is 60. So this is 3c is 60. Now value of e becomes 0. The iteration terminates, right? So now this 3c is to be added in the next iteration. So now value of c becomes 3c. D is getting decremented to 2. Now that 2 is being placed to the variable e, right? Okay. So now again what I'll do is I'll add 60 to 0, right? This becomes 60. E becomes 1. I'll add 60 to content of accumulator. Now this becomes 120. Value of e becomes 0, right? Okay. So now D is getting decremented by 1, so D becomes 1 further, right? Now the value of A will be retained by the variable C, right? Okay. So now again A is reinstated with 0, so 0 plus 120, right? Okay. So 0 plus 120 is 120, so value of E becomes 0, right? So this is the way how the progression is basically done. So again I'll repeat it. So initially value of D is 5, 5 is getting is being retained in C because initially the addition has to start with 5, right? Okay. So now D is getting decremented to 4 because I need to find out how many number of times addition has to be done. Now that D is getting retained in E, right? Okay. Because at the end of iteration, it may so happen that if you do not use any alternative variable, D may be 0 and it may be very difficult to run the successive iteration. So in order to prevent that, value of D is getting retained in E, right? Okay. So the initial value of A is 0 because any operation is performed using the accumulator. So 0 plus 5 is 5, 5 plus 5 is 10, 10 plus 5 is 15, 15 plus 5 is 20. So once it becomes 20, the value of E becomes 0 and the iteration terminates, right? So now the starting of the next iteration, before the starting of the next iteration, D is to be decremented by 1 because the number of addition that you need to do will be 1 less than that of the previous iteration. So you need to start with the output of the previous iteration. So now C will be 1 4. So here there is a typo error. This is 1 4. Okay, right? Again, so E is D is getting retained in E. So again, so 0 plus 20 is 20. 20 plus 20 is 40. 40 plus 20 is 60. Right? Okay. Now E becomes 0. So we need to stop the iteration and then decrement D. So D is decremented by 1, so D becomes 2. The previous output is getting retained in C. Again, A is to be reinstated to 0. So 0 plus 0 plus 60 is 60, right? Again, and 60 plus 60 is 120, so 8 is 120. So value of E becomes 0, the loop terminates. Now the value of D becomes 1, right? Again, and 8 is retained in C, right? Again, so now again I need to run the iteration for one more. I need to perform summation for one more time. So 0 plus 120 is 120. The factorial of a number 5 is 120, so that is equals to 78. So 78 is a hex representation for 120. So this is the way how the factorial of a number has to progress, right? Okay. So here what you need to keep track is you need to keep track of how many addition is to be performed in the initial instance, right? Again, and how to retain the value from the previous execution, right? So C is used to retain value from previous execution. Here again, I'll repeat it. This is a typo error. This should be 1 4, right? Okay, and how addition is to perform. So what I need to do is I need to go to a particular iteration. I need to perform summation and then terminate and start with another iteration, again perform summation until unless the condition is satisfied. The moment the condition is not satisfied, so you need to terminate the execution, right? So this is so here what we have is we have very simple concept node, right? So D is initially D is initially 5. So as I've said, D is saved in C, right? Again, so C is initialized with D, then D is decremented to 1, right? So now then A should be 0 because addition is performed on the accumulator. So initial value of A should be 0. So then D is moved to E, as I've already said. Then what I need to do is I need to continuously add C to A, right? Okay, until unless E does not become 0. So moment A becomes 0, the loop terminates. Then the value of A is to be retained in C because in the next iteration what I need to do is I need to add the previous value of A, right? Then D is decremented, the process is repeated until unless D does not become 0, right? Okay, and eventually the result will be placed in C. Then C is moved to A, right? Again, and then the content of A is moved to some specified address location where the result is to be stored. So this is the way how factorial of a number is to be realized. Okay, so here what we need to keep track of is since it has a nested loop in it, you need to keep track of the control variables that are capable of controlling the execution of the various set of instructions, right? Okay, so this is the way how factorial of a number is determined. So thank you for today's class. So we'll meet up in the next class.